laptop. On my home network, instead of going to the laptop, it goes to a router, and then the laptop goes to the router as well. So they do DHCP to start with. Tonight, I've hard-coded the addresses of master.local, node 1, node 2, node 3 on this little example because I don't have internet access here. So keep in mind you will need a DHCP server. But the names that I use to flash those are master, node 1, node 2, node 3. If you have 100, just keep using node, and it'll work with my magic that I'm about to show you. So who likes magic? All right. So Ansible is magic. I don't know if anybody uses Ansible. Yeah. Brew install Ansible. You should do that immediately if you have a Mac. It is awesome. It'll do everything for you. It'll automate all the things. It can manage your Linux, your Windows, your network, everything, your cloud stuff. It's awesome. So I wrote this application called the Docfather. And the reason I wrote this is so that everyone can have the Staples Easy button, and you can bootstrap your Pis using the Flash tool, install them, run the Docfather, and you'll have a running swarm cluster with Docker on your Raspberry Pis. So hopefully this video works. So this is what it looks like when I run the Ansible. Basically I can't do that right now because I don't have internet access. And Ansible will do all kinds of things, but the Docfather, it will go out and collect some things that Ansible needs to run. It'll take and ping all your nodes and build the inventory file for you. So then when you have your inventory file, you can execute against those. It basically only runs two commands. The first of which is an Ansible raw command. And the reason it has to run raw is because Python isn't installed by default. And Ansible needs Python to run. So you see this Ansible cluster is what it's targeting, -I, inventory is the file, the -m is the module you're using, -a does the sudo apt update and gets Python. And then the -k, if you have SSH pass installed, it uses the one without -k. If you don't have SSH pass installed, it will prompt you to type in Raspberry. Now after it gets installed with Python, Ansible can actually run. And it will run an Ansible playbook with site.yaml, and it does the same thing again if you have SSH pass. Now the second time through, it's going to install two roles. And what we'll see here is that you have a couple variable files, and then in here it installs a common role and then a role called os_swarm. Now what that does is a common role, it will install a bunch of base packages, it'll copy up the Docker config to make it listen on a TCP port, it'll do a bunch of fancy stuff, and then the next role will come in and it'll create the swarm for Docker to run. And here's what you'll see when you run it. So follow as seccpc, right? And then it'll run, you'll see all this, the Ansible and Ansible playbook down there, it validates that you have those. If you don't have those, it's going to spit out a different message. It scans for SSH keys because Ansible gets pissed off if you don't have the right SSH keys, and it adds them to your known hosts. Now it builds the inventory file for the Python first run. Now it's going to take a while for all this to run, so I split it up. So continuing on, the first time, Ansible wants to talk back in JSON, and this is what you'll see when it does the raw run. You'll see that the host names, or the IP addresses of your nodes, and you'll see what it did, like basically coughed out to the command line. You'll see that it did the update and it installed Python and a couple other dependencies for Python, and it did it across all 4 hosts, which is pretty cool. I mean, it makes it easy, right? After it installs Python, it has all the dependencies it needs to run the actual Ansible playbook command. So once this all goes down, then it's going to bootstrap using the Ansible playbook. And it's basically the same thing over and over again. So now it gathers, you see it says executing bootstrap playbook, and then it gathers facts. It'll tell you, IP address, host name, stuff like that. The common role, you see common pipe, and I'd like to thank Rick Bryce for helping me with the common role. The common role runs and installs all these packages, Python dev, Python pip, htop, iftop, a bunch of other stuff, OpenSSL, nmap. And then it runs through and it stops Docker, and then it pulls down Docker 1.8.1 from Hybrid. It installs it. It keeps going, removes the old install file, the package that it pulled down, the deb file, and then it'll restart Docker. It does a couple other things. It adds a fancy MOTD. It'll also add in your public key to the SSH authorized users or authorized keys file, assuming that you copy it into the common roles file public-key.txt if you git clone this from GitHub. It'll update Docker config, like I said earlier, so it listens on a port. It also does that, sets a public key. It also creates a command called master.doc, and now master.doc is a command that I made for Swarm. If you're on the master, you can say master.doc and it'll automatically tag in the -h TCP and then the host name with the port so that you don't have to type out all that crap. You can just say master.doc instead of Docker. Now this, it's going to be common the first time you run this to see this failed, because what it's doing is it's going to remove the container. If it exists, it's going to remove Swarm Manager. It ignores the errors and continues on. It does the same thing for Swarm Agent, so that if you run this more than one time, it'll continue to work. Now we're getting into the Swarm. It's going to make this Jinja template. It's going to copy it up as a script to launch master if your host name is master. On the other one, it's going to copy up the launch slave if your host name is node whatever. So once all that's done, you'll see the play recap, and it'll show all the things that are changed. Everything's done. Docfather has ran, and now your Raspberry Pi 2s will have a running Docker Swarm cluster that you can use. Pretty cool. So what just happened? You can get this code for free down there at GitHub. Basically, Ansible just did all the work that I struggled to get through to make this dance. So you went from this, where it was prompting for the password and it's asking you all this stuff, and you see the client version is 171, the API version is 119. And now you got this, so it logs you right in automatically. It's got a kick-ass MOTD. It's got a couple other things. It's updated to 181, and your API version is 120. So we want to SSH into these things, right? So if you're not familiar with Docker, the first things you do, just run in and look at what the processes are that are running. If you see here, I run Docker PS, and you can see container F6114C, whatever, is running Hyperion Swarm, and it's been up for a couple minutes. And that's the only thing we have running currently. So to do hello world, hello setkc, basically you do something like this. Docker run, and then you -IT interactive with a TTY, Hyperion RPI Alpine Scratch is the image that I'm going to run, and then bin sh is the command, so then it pulls down that image and it lets me in to a Bourne shell, and then I can run hello setkc and look at the host name and you see the container ID. So when you're on the outside looking in, what happens is you still see the Swarm running, but you also see now the Alpine Scratch that's running in Docker PS, and not Docker PS -A, because that's a different deal. So some useful stuff. Docker PS will show you what's running right now. Docker PS -A will show you everything that's running and everything that's exited. Docker stop and then piping into Docker PS -AQ. It'll get all the container IDs and stop them. And then you can remove them as well. Docker images, if you pull down images, you'll see them in var lib docker and overlay or whatever your file system driver is, it'll store them there. You can remove the images using remove RMI image ID, a couple other things. One of the cool things is the Docker logs with the container ID or the container name. Some useful flags, you can use -P, so if I say port 9999:80, I want to expose the host port 9999 and bind it to the container port 80. And then the same goes for V. It's host volumes. You can mount files into the containers and whatnot. So in this example right here, Docker run, I'm running at -V, which is daemonized. I'm passing in port 80 to 80, 70 to 70, and I'm also mounting the volume root HA proxy comp to HA proxy override, and I'm running the container Hyperion HA proxy. So here we're going to clone down a compose example, Docker compose. And I CD in there, and you say Docker compose up, and it should just launch and build these containers on the fly, because if you look at the compose file, the Docker compose file, it calls the build dot, which builds those on the fly. So you see these containers getting built with Nginx and copying things in. Once they're successfully built and everything comes up, it'll say that it linked all these containers together, and it'll stop, and then I'll flip over and show you, hopefully with, not. So basically this is what you're going to see. Welcome to the sexy Docker show. It'll have the host name for each container with a fun picture there. Now, behind the scenes, port 70 exposes the HA proxy interface, which you can see down here on web A. You probably can't see this in the back, but there's only one hit, and you can see the in and out bytes and whatnot. So, everybody always says Docker has all the things. Here is an example of Dockerizing the Apache Bench program. So, these lines of code up in the top left, you say from Hyperion, RPI, Alpine, Scratch. It's going to inherit from that. And then it's going to run apk add Apache utils. The entry point is going to be AB, which is Apache Bench. So on the right, you can see it getting built. You just say docker build -t, your tag, go to Docker Hub, get an account. You can make a whole bunch of containers. Hit dot, and then it builds this container. Then after that runs, you'll have to run it -d. It'll generate another container ID that you can then commit to your Docker Hub repo. So here it is in action, hopefully. If I run Apache Bench against that same cluster that I just brought up with Docker Compose, you'll see there's 100%. It did all the requests. It's doing however many. But that one window where I only had one hit, if I refresh that now, you're going to see that that now has balanced across the containers, and they have about 29 to 30 hits each. So it seems legit, right? Like, pretty cool. seems legit. But you made a website, right? Like, that's cool, but where's your hackers? So, what I would say is you should Dockerize all the security tools that you can. My Docker Hub is getting to the 3rd page now, and I'm just like cranking crap out all the time. So, I started with ping and then Apache Bench, and then I tried to do nmap and metagoo file and set and a few other things. But yeah, I can has nmap now. So I can just run nmap as a container. I say docker run -d, add a mouse RPI nmap -p22, and I scan one of the things and it runs it as a daemon. I do a docker ps and you don't see it in the list because it's already scanned, it's already completed, and now it's in the logs. So I run docker logs b1622 and it shows me the result. Pretty cool. So I have a swarm cluster set up, right? And what that basically means is what Docfather did earlier was built a master with all these nodes attached. Now you see here node 1, node 2, node 3, and you can see how many containers each are running and all that. To access those, you run this master doc command on the master, and it will talk to port 3, 4, 5, 6 on the host, and it will then talk out to all the nodes on your behalf. So what if I did something like this? I set an environment variable called engagement, and I call it setKC, and I do for I in sequence 240 to 243 because that's the IP address range of my pies here. And I do export IP equals whatever to $I, and I do master doc run, and then I name the container setKC underscore IP address, and I run the nmap against it and pass the IP, and then it says scanning whatever. Pretty cool, right? So when you look at it, docker ps -a, and I grab setKC, you can see that it ran 4 things, and the first one ran on node 3, then node 2, then node 1, then it started back over on node 3. So it farms it out across all of them. Now you run master doc logs, and you can see the result of your nmap scan. So what about constraints? One thing that Docfather did when it copied up the files is that it made this etc default Docker file. And it populates this label disk equals master with the host name. So having that information, you can then call constrained containers. You can run things and say only run on this. So for example, hold my beer, from master.local, I'm gonna have node 2 scan node 1. So I run master doc run -e constraint disk equals node 2, and then nmap, and then that's the IP of node 1. So you do a master doc and grab nmap, then you do the logs and it shows the result. Kind of cool. Things that suck. I can't do my whole demo because I found out today that when you're running a swarm, it beacons out to here when you have your token set. It tries to talk to discoverystage.hub.docker.com and it puts in all this stuff, which that's bad because that's your swarm ID. So there's probably some investigating to do there. I wouldn't doubt in the future you'll see people trying to attack microservices, and In the docs folder of Dogfather, I believe I put in all the commands to run to generate your own CA and build up all the certificates you need to run TLS so that that doesn't happen to you. So when I have the internets, I run Swarm only, which is also in the folder with Dogfather. And it'll run, and it'll basically, all it does is just run the Swarm role. It'll log into each of the pies, and it'll start up my Docker Swarm. Because you don't need to run the Dogfather every time, only when you do it the first time, because I don't care about the common role except for when I'm bootstrapping the first time. So, after all that, just set up your Docker Swarm. Done. SSH into the master. Become root with sudo. PS, you should see your Docker Swarm running. And if you do an info, Docker info will only show you the local, but if you do master doc info, it'll show you all the containers that are contained in your swarm. So yeah. So roll your own containers for fun and profit. It's pretty cool. You can go to Docker Hub and get a free account. Just start cranking out containers. It's pretty easy. Building Docker files. So I started with this. It's like, yeah, I ported a few things, but if you really want to be balling, you need to be running Metasploit, right? So I pulled down Debian or whatever it was on ARM, and I did all this stuff, and I did the Ruby battle with gems, and I fought, and I got Metasploit to run, and it was 2 gigs. Down here you see the container size is 2 gigs. That's ridiculous. Nobody wants a 2 gig container. So this was brand new to me. I had no idea this was even going on. After I fought that fight for a few days, I found this, and I was just blown away because they provided a bootstrap script, which if you get the bootstrap script off their site, what it ends up doing is building you a Kali version 1 Docker container, which is pretty cool. But with a little bit of manipulation, you can change that to a Kali version 2. And so out of that came this, the RPI Kali 2 Metasploit Docker Hub repo. If you see it up in the top right, it's only 500 megs. If you get the latest, 502 megs. So it's pretty cool. It looks like this when you start it up. Yeah, it looks like this when you start it up. I'll show you that here in just a minute, actually right now. So let me end the show. So the first time you run this, if you haven't downloaded the image, it's going to pull the image straight from Docker Hub, and you'll see a bunch of stuff about pulling file system layers and all this stuff. But I wrote the entry point for this. I was having problems with connecting the database with Metasploit, so what I did was I put some weights in here, so you see this nice database is starting up message, and it'll delay a little bit. But basically what's going on behind the scenes is it's loading the container, and it's starting up Postgres, and it's attaching everything, and it's going to drop you into a shell inside a container that is actually Kali 2.0. So we'll see that hopefully pretty soon. And this is just a troll here preparing shell access. That's just because I'm making it wait so long. So sorry about that. So here we go. It's now dropped you into Kali 2.0, and just trust me, no. If I look at the Debian version, you can see it's Kali 2.0 there. And we run MSF console and we wait for some more, because it takes forever to load Metasploit on these things, but that's not a big deal. So basically this is 1/4 the size of the original container I started with, which is based on Debian, I want to say Jesse, possibly. I inherited it from, I think from Debian repos. But building all that stuff sucked. It's a lot easier to build a container and just say install Metasploit. And thank you to the guys out there that built the bootstrap thing, because I was able to tweak it just enough to run it on Raspberry Pi. So Now if you get a Docker, or if you get Docker running on your stuff, you can just say run RPI Kali 2 Metasploit, and you'll have this at your fingertips. Now, one thing to keep in mind with the port exposing, if you're going to have handlers and stuff, so you want to expose the ports on the container to the external host, and you can move these around, right? So if you have multiple things in your swarm, in essence, you could run Metasploit on a variety of different places. And I think in the future you'll see some of that. Come on. So there we go. When it loads, this is what you're going to see. The banner was hacked a little bit. Docker image for Kali 2.0, Raspberry Pi 2 ARM. Follow us at KC and press the Trixie. DBM map 192.168.7.243 to prove that it's working. Searching takes a while. It has to do the index. You might have to re-index your stuff. Typical issues. I should have limited that to port 22. While that's running, I want to show you something else, and I'll come back to that. So, I've done all this on the Pis. There was some stuff I couldn't get to port to the Pi. I tried and tried and tried to get Mesos to compile, but I just never could. So I have this example that I saw that I've kind of customized a bit that I want to try to do here live. I don't know if it's going to work or not, so we're about to find out together. So it looks like it's going. 2.168. Oh.
Browsers.com.
Oh, failed. There we go. So this is the Marathon interface. You can see a whole bunch of crap going on in the background. What I'm going to do is launch an application on there, and it's going to run this Marathon, and it's going to post it to the host. It's going to create an app called Osweb. It's basically just a JSON. So you see it here, it's starting to spin up. We're going to have 10 instances of this. It's going to take a minute to deploy. But basically, it's going to keep rolling out containers to however many we tell it to. So you can scale this on the fly. It's pretty slick. There we go. So DBM map ran. Listed in the host, so it's connected to the database. That works. So have fun with that. Enjoy that. So I'll go back to the web interface, the GUI, as everyone loves. It's on 5 of 10. As soon as that's done deploying, what I'm going to do is I'm going to do an in-place update right after I show you that this is what it looks like. Right? Thanks for coming out. Sign up for talks. Pretty cool. So after this app's done, this is running local on my VM right now. But in theory, if you haven't seen the DCOS, which is the new hotness, basically they're trying to abstract the host and the application and all this microservices stuff. It's pretty slick. It's pretty awesome, actually. So right now, you see the gray bar. It's doing the installation. The green is completed, and we're on 8 of 10 right now. So as soon as it gets up to 10, what I'm going to do is I'm going to do an in-place upgrade of this service, and it'll just roll across all of them. It'll oversubscribe by 10%, and it'll do an in-place, just roll through and update all of them to version 2. But I have to wait for this to finish, otherwise it gets upset with me. I have a problem with patience at times when working on this stuff, and it doesn't like to have more than one command issued to it at once. So it's still status running, so now you can see we're 10 of 10, we're good. I'm going to run this Marathon 2, and what it's going to do is it says hit the host, app update OS to version 2, and we watch here, it's in state deploying. It's going to roll through and do a live update on the fly of all the containers that are for Oswebs. And the blue is the oversubscription. It's currently in update phase. So if I go here and I open this in a new tab, hey, seriously, you should sign up and give a talk. So, there it is. Any questions?
Good job.
What up?
What does Docker do?
It runs applications in a contained format. So basically I can run a bunch of stuff on, it's supposedly going to abstract the host, right? Like if you compile it on CentOS, you should be able to run it on Ubuntu or different formats. Now, Microsoft's coming out with their own version of Docker, supposedly with their next release that's going to be inherent to that. But really, it's just works with the Docker API. They have their own container format, and there's a lot of violence in the container format. Even Ubuntu has their own thing that are called charms, and so they have an open container format initiative, like to try to get some kind of governance around that. I don't know if that answers the question or what, but yeah, basically I can run virtualized instances of applications on whatever, if it's Raspberry Pis or my laptop or whatever you got.
So shared services for, let's just say that you were doing the Nmap, and you were doing history. I think that's what.
Yeah. So
if I had, would you see Docker as being a tool for like red teaming?
Possibly, because I haven't really seen anybody looking at the security side of this thing.
So I was doing the history command. If he was in there as well, would we be signed under the same account? Do you even run the history command to see like vulnerable services?
So I don't know that there's history, but there'd be logs, right?
Oh, sorry, logs.
Docker logs. Docker PS-A, and that'll show everything that's there. But the problem is,
so if like I ran Nmap and he wanted to also use the same,
it's going to spin up a new container ID. So like,
I didn't know if we could share that same, like since
yes,
I've already ran it.
I would think so. So on this, I'm logged in as root, and if you're all logged in as that, and you have access to the Docker daemon, you should be able to just do Docker logs and pass it the name or the container ID. 64, and it'll show you the output. So that one didn't work. Hold on. Docker PS-A. If I have it in that one. Docker PS-A. Docker logs 70D5. So you should be able to get that information right.
Do you see deploying Docker like something with Heroku or anything like that?
I haven't seen that yet, but I think we're going to start to see more people using this for security tools because it's portable. You don't have to have all the installation of everything. And if you look at this, like I do Docker images, here's where you'll see everything that's installed, right? Like, and it pulls it live. So if you don't want ping, RMI, RMIs, RPI, ping, then it blows it away. Docker images. So basically you just wiped out all the history of that. So now you're going to get into the forensics aspects of the different file system drivers, which is a little beyond what I'm doing here, like the overlay and the AUFS and all the ButterFS and all the different things. But yeah, I totally see this being like popping your Swarm token and taking over your cluster and like getting into console or Redis or everything. Like all these people are microservices are the new hotness, and I don't doubt that you'll see people start attaching these very soon. Sweet.